Okay, so we saw some of the basic methods in the counter class, in our server class, which is called counter. And we saw how to implement queries, commands, how to implement a constructor next. Well, all you have to do is initialize the instance variable count, which is private. You want to initialize that to, let's say, 0. You could do other values, but 0 is good. 0 is a good one. How do you do this? You just say in your public counter constructor with this is a default constructor, no parameters. You set count equal to 0, semicolon. So that's a Java statement saying left-hand side count is assigned the value of this expression, which is just 0, simple 0. Remember, you can have overloading of constructors in Java. Java does allow you to have multiple constructors. So you could pass in a value which you can use to initialize this instance variable count. In this case, we are just using one constructor with no initial value, which is by default assigning the value 0 to the count private data member or instance variable. Okay, so we can have methods with parameters. Often a client must provide additional data when invoking either a constructor. Remember, Java does allow overloaded constructors. Overloading, you can have multiple constructors, any number, there's no limit really. Or for any method you might pass in parameters to. So additional data provided are called parameters. If you take a look at the structure of Java programs, the basic organizational structure is that you have a package, which is a collection of closely related classes. Now there are things about visibility that have to do with packages. We'll get into that in the next lecture or the next set of videos. And so we'll talk about that later. A compilation unit is a file containing the definition of one or more classes of a package. So for example, in what we've been doing right now, we have a P1 package which contains client.java, it's a compilation unit, main.java is another one, and server.java, 3 compilation units in one package. You can have multiple packages like P1, and I have, in this case, I don't know, I'm hoping you can read this. It says P1 counter, which has the counter.java compilation package, counter tester, and main. So these are related together. I mean, these are related, so we keep them together in one package. That's typically how we organize our programs. Although you can, in this case, for example, in main, I can actually use server or client. So how do I do that? If I'm in a class like this and I say I want to use from P1 counter, I want to use a class from P1. I'd say server s is equal to new server. I can try to do that. It'll give me an error message and it'll say that server cannot be resolved to a type. What it's really saying is I need to import something if it's in another package. So I want to import p1.server, and now I'm good. No more error message. And I can print it out or whatever. Remember that when you see these things, this is like a exclamation point in a triangle. That's just a warning. It doesn't mean there's an error, but you want to fix all your warnings as much as possible. So I can just say system.out.println s is, and as soon as I reference this variable s, I'm reading it, and so now the compiler is happy. No more warning. I hope you've seen this before, I hope, but if not, here's a nice tip. Okay. Let's go back to our notes. I'm hoping all of this makes sense. You can have multiple packages, you can have multiple classes, and each .java file can only have one public class. You can have as many classes as you want, but only one can be public. So in A1.java, the class A1 is public, and the class A3 is not public. In B1.java, B1 is public, B2 is not public, and so on. A2.java can be in package A, and C1.java can be in package C. So you can have this in any place that you want. They don't even have to be in separate in the same source folder. You can have multiple source folders with the same package. That is possible. Actually, that's not actually shown here, but that's an Eclipse thing. So, all right. So if you want to refer to a class in a different package like we did just now, we imported the server package from, the server class from the P1 package. So you can say import package name dot class name. Now in the past, I'm sure you've used this import package name dot star, for example, javax.swing.star or javax.swing.border.star. For starting from now on, you want to specify every class that you import. You want to specify it explicitly rather than using the star. Why is that? Because when you use the star, it brings in all these names from this package. And what if you want to set up your own class called line border for whatever reason? Well, now there'll be a conflict. And if you use this, if you use the star, and you did not want line border but you want something else from this package, well, you can't set up your own class called line border. But if you do, you'll have various conflicts. So for many reasons, you want to specify each class that you import explicitly. That is, specify the name. Even if there's like 10 different or 20 different classes that you're importing from a specific package, you still want to name every single one of them. That's the rule. Why do we use import statements? Because the alternative is kind of wordy. Let's say you want to create a myBorder object that's an instance of the line border class. This is one way of doing it. You specify the full path javax.swing.border.lineBorder. That's the name of that's the type of myBorder. And then when you create it, you have to say myBorder equals to new, and then the same thing all over again, javax.swing.border.lineBorder. And once you import it, you can make this a lot easier to read. This is definitely easier to read. If once you import that class, you can say line border, myBorder, rather than javax.swing.border.lineBorder. And then when you create a new instance of that object, you don't have to specify the complete path. You just say line border because it's imported. Okay, so there's a lot of advantages to importing, but sometimes, every once in a while, you might see these kinds of statements too. Okay, so there's a predefined package, java.lang, which contains all the things that you need in Java. By default, things like string is used just about in every Java program, so you shouldn't have to import these kinds of standard things. So these predefined package, java.lang, contains definitions of a number of commonly used classes. You do not need to explicitly import this java.lang package. Java does it by default. It's a nice thing. Otherwise, every Java program would have an import java.lang.string or java.lang.star, but this is done implicitly by Java by default. Okay, that's it for chapter 2 of the book. The next lecture will be more on basic Java classes. I'm hoping that most of these things that you saw in this lecture and this video and the last 2 videos you've seen before. Hopefully, if not, if you've seen it before, it was still a good review. And we see more of this, maybe things that you've seen before, but it's definitely, I think, good to review all of these topics. Okay, so try looking at chapter 3, some of the examples, and I'll go over that in the next set of lectures.